Thanks everybody for your patience. I am working through today another two-sample dependent t-test, and I have a fact pattern to your left. It reads a social worker or a social work educator is interested in understanding whether students do better when lectures on telehealth are presented online or through in-person classes. To test this, she takes a random sample of two groups of 20 BSW students at Sacramento State and randomly assigns them to either online or in-person telehealth classes. At the end of the semester, she examines the test scores for both and finds the following data. The average difference between the groups is -5. The sum of the average squared is 202, and the sum of the average is -57. Based on these numbers, please solve for the two-sample dependent t-test, and I have the equation for that right here, and you can see that everything we have is already here. We see that there were 20 students. Okay, that's going to go anywhere there's an n. Okay, we can see that the average difference, a bar over anything, is going to tell you an average, so that's going to go there. Okay, the sum of the average squared, well, this is the sum of the average squared, and the sum of the average is -57, which will go right here. We notice that we'll plug that in, and then we're going to square it after it. So sum of difference squared and the sum of difference squared. They're very different things. So why don't we set this problem up the way we normally do? I'm going to go ahead and put the t there. Okay, I'll set this up like we would any other problem, and I'll try to do it with some level of neatness. Okay, we'll put the -5 there, because of course the -5 is going to be the average difference, and there it is, the average difference. It's right there. Okay, I'll set this up for you. That's better. Okay, so we have for the denominator, the numerator and the denominator of this one. Okay, we know that 202 is going to be right here. And why do we know that? Because the sum of the difference squared is the same thing as written here. Okay, I'll see if I can get that for you. The sum of the difference, or the sum of the average squared. It should be the sum of the difference. Sorry about that. I'll fix that right now. There. Okay. So that's 202, and that's going to actually be a minus sign there. Okay, we know that the n is 20. I mentioned anywhere you saw an n, it's going to be 20. We know that the -57, okay, it's going to be here. That's a 7. There we go. It's a nice little 7. Okay. And squared. Okay, and we already know we're going to have 20. And 20 minus 1. There we go. Well, the 20 minus 1 is going to be pretty easy, so I can take care of that relatively quickly. So I'll just go ahead and back that up. So we already know 20 minus 1 is 19, so we'll go ahead and back that up. We'll just put the 19 in there so we know what that is. Okay. There you go. So we'll just go down here and do a little bit of math, and it doesn't take much. It's only a couple of operations that we have to really deal with here. See if I can get a straighter line this time. Okay. Carrying all this down. Kind of do a little bit of calculating as we go down. Okay. So, for example, why don't we try this one really quickly? I'll go ahead and do this. First of all, go ahead and open up this one. We'll go to calculator, because you can actually see my calculator when I do it this way. When we're in Zoom, you can't see my calculator, so it's easier when I have a video of it. But let's just go ahead and do this for the fun of it so we know what the numbers are. So let's just handle our denominator first. We'll say 20 times 19, and that's going to give us a number, and that number is 380. So we'll go ahead and put the denominator in right now. There you go. And we'll just carry this 202 down also, because it's not going anywhere. It's not going to change at all. We're not going to do much with it. Okay. All right. The only thing we have to do any kind of major calculations with are right here. Okay, negative 57 squared over 20. We can take care of that pretty quickly. Okay, I'll go back to my calculator, which is actually right here. I'll say this. Okay, 57, and there's actually a little neat function here on your calculator. You can hit the plus minus sign, and it'll give you the negative, and then the x squared is just going to square it. So it's going to be a big number. It's going to be actually. So what we'll do is we'll say. So if we square it, it's going to be 30. It's going to be 3249 or 3,290. I'm sorry, 3,249. That'll be right here. We already know we're going to divide it by 20. So we'll just go ahead and go divide it by 20. Okay. 162.45. 162.45. All right. So probably the easiest way to do this, okay, will be to go ahead and, since you've already seen this fact pattern, we don't need it anymore. I'll just go ahead and move it over a little bit, make this a little bigger for you. Okay, and so again, we'll just carry over -5. The all-important square root is what we need to make sure we keep, because that's what a lot of students forget. All right, so again, this isn't going anywhere, so we'll put the 380 down here. There we go. And we're getting there. We're working our way through it. Okay, we'll go 202. And what are we subtracting from 202? 202 subtract 162.45. Okay, so we already know what that's going to be. 39.55. There you go. And nice sloppy writing. Okay, so we'll come back here, 39.55 divided by 380. We know it's going to be a small number. Okay, it's going to be a small number indeed. It's going to be, we'll just go 0.10 rounding. Okay, so we'll go ahead and do it this way, 0.10, and we're going to take the square root. Okay, and actually, once we do, we're going to go ahead and actually, to make this easier, we already know it's going to be 0.32. So I'll get rid of that, and then I'll do it this way. I'll just erase all this out. There we go. 0.32. Okay. So once we do that, that's pretty easy. I think we can kind of see what we're doing here, because we'll just go to the 5 negative, okay, divided by 0.32, and this is going to be a bigger number because if you split 5 that many ways, okay, there you go. It's going to be negative. I'll bring that back up in a second. 15, I think I saw it. Is it 62? Oh, yep, 63, because we're rounding. Okay. What have I always told you about the t-test calculated? It's going to be a absolute value. Okay. The absolute value is going to be that number without the minus sign. So, okay, the absolute value of t for this particular case is going to be calculated. Okay. All right. So we already know the absolute value is going to be 15.63. We only have 2 things left to do now. Okay, one is to consider the calculated and then consider the null hypothesis. So let's take a look at the, since we already have the calculated, the next thing we're going to need to find is the critical. Okay. And the critical in this case is going to be found once we find the degree of freedom, which we already have. And the degree of freedom, okay, in this particular case is going to be n minus 1, so I'll just put that up there so you know. Okay, n minus 1. In this case, the n is 20. So if we say the degree of freedom is n minus 1, we know that the degree of freedom going to be 19. So degree of freedom is 19. So the only thing we have left to do is take a look at our books and come right back and figure out what the critical value is. So I'll go ahead and do that. So after conferring with the critical value chart on page 93, I found the critical value for a 0.01 or a 93. Okay. 2.093 is going to be the critical value, and clearly we can see in this case that the calculated value 15.63 is greater than 2.093. So now what we can do is move this over a little bit. I guess I can do that the opposite way, huh? Sure can. And then I can move that over, come back here. Null hypothesis. Okay. You already know what a null hypothesis sounds like. First couple words are never different. There's no, not, or there is no significant difference between the average grade or online and in-person telehealth courses. Okay, and if I wanted to be real specific, at Sacramento State. Okay, so that was my null hypothesis. And since I already went through all this and tested it, what I can do is simply just say, what do we find here? And if I come back and I look at this one more time, I think you recall that the calculated value is greater than the critical value. And if that's the truth, we're going to reject the null hypothesis. So what is that going to mean? Okay, well, let me come back to my chart, and that'll help you a little bit. Okay, we'll say in this particular case, we shall reject the null. Okay, and now you know one more thing. You know that if we rejected the null, okay, p-value will be equal to or less than 0.05. Well, let's see if I can make that so it's a little clearer for you. There you go. So that was how you solve that one. That's another two-sample dependent t-test. So hope that helped you. Again, what we're doing right here is figuring out when you get a new fact pattern, it could be any new data, how do you plug it in to the equation, and what do you do in terms of resolving and interpreting the results? I hope that helped. I hope you're having a good day.